Hello everybody. So today I will talk about calculus. The topic today is about differential equations. So now I will show you how to answer. We apply about Cauchy-Euler. So I will put about YC. That's about complementary solution. And that's about S to the power of n. Now if I do first derivative, we have n s to the power of n minus 1. Second derivative, we do first derivative of this one. That's why we have n minus 1. And s to the power of n minus number 2. And we do third derivative, we have n minus 1. N minus 2, and we have s to the power of n minus 3. Because this is about complementary solution, so this one should be equals to number 0. And now we need to put this one go in here, this one go in here, this one go in here, and this one go in here. So we have s to the power of 3 multiplied by s to the power of n minus 3. You will go about s to the power of n. Similar for this one with this one, and this one with this one. So we will have about n multiplied by n minus 1, n minus 2, s to the power of n. About this one, we have 5 n minus 1, s to the power of n, 2 with this one. So we have 2n, and we have s to the power of n, and y we change by this one, and that's about negative 2s to the power of n. Now we have s to the power of n. We can do about factorization. And now we need to expand everything in here. So we just concentrate about this one only. So I will have n multiplied by n squared, and 3n, and number 2. So we have n to the power of 3. This one we have n squared, negative 3n squared, 5n squared. You got about positive 2n squared, 2n, negative 5n, 2n in here. We have negative n. So we put negative number 2 in here. So we find the solution of this one in here. So we have n equals to number 1, n equals to negative number 1, and n equals to negative number 2. So we have yc in here. So we have c1 s to the power of number 1. So we have s, c2 s to the power of negative number 1 we put in here. and C number 3. That's about S to the power of negative number 2. And now I will go to particular solution. We see that we have S to the power of 4. That means we need to put about YP equal to AS to the power of 4 in here. Now, for this one, we need to find first the derivative of YP. So we have A and number 4 in here, S to the power of 3. Second derivative, first derivative of this one, you got about 3s squared, number 3 with number 4, we have 12. 12as squared. And the last one, that's about third derivative. If we do first derivative of this one, you got about 2s, number 2 and number 12, you got about 24as. And now we put this one go in here, this one go in here, this one go in here, and this one go in here. So if we look carefully, we can see that this one multiplied by s to the power of 3, this one multiplied by s squared, this one for s, and this one for y. So we will have about 24as to the power of 4 plus number 5 with number 12, you got about 60as to the power of 4. The next one, number 2 with number 4, we have 8as to the power of 4. And the last one, that's about negative 2as to the power of 4. Now we simplify everything in here. And we got about 90as to the power of 4 equal to s to the power of 4. That's it from here. So that means this one is about coefficient number 1. So we have 90a equals to number 1. Later that we divide both sides by 90. So we put 1 over 90 go in here. And now we got the final answer. That's about yc plus yp. Yc, we just have this one in here. So I need to erase this one. And yp, that's this one in here. And this is the final answer we need to find in here. This is the end. Thank you for watching.